So let's talk about total distance traveled. All right. And total distance traveled is going to be one of those applications of the net change theorem that we want to take a look at a little more closely. What you need to realize is that when we do the net change, any values that fall under the x-axis are considered negative, and then any values above the x-axis are considered positive. So one thing that we want to take a look at is um, finding the total distance traveled by a particle that it's in motion. Is it a little bit different than net displacement? The net displacement can be negative, but the total distance traveled is always positive. So what that means for us is that as we analyze our situations, any parts of our function that fall below the x-axis, right? So if we have this and we've got this piece of red that's below the x-axis and we've got this piece of yellow that's above, in order to find the total, right, the total accumulated value, the red part, we've got to take the absolute value of that. So when we do our math, it's possible for us to get a negative value. We just take the absolute value of that to make it positive and combine it with the other values. So I'm going to illustrate that as we go throughout this PowerPoint. If you take a look at what we have in this problem, when you go in and look, you're going to see that the PowerPoint has worked this out a little bit differently than what I'm going to do. Okay, and there's a purpose for that. I really like for my students to be exposed to a number of different means by which to solve the problem. And so that's what I'm going to do here is I'm going to solve this slightly different so that you can see how it plays out. So first, what we want to be able to do, let me go in and insert a slide right here. So just so that I have some area to draw on and you can see clearly because some of these slides get a little busy. Okay, so right here, what we want to be able to do is in the problem we just finished looking at, right? This one right here. It says, given the velocity function v of t equal 3t minus 5, in the previous video, you looked at how to find the net displacement. But what we want to be able to do is we want to find the total distance traveled, right? In this example, find the total distance traveled by this particle over the time interval 0 to 3. One of the most important things we're going to do is take a look at the t-intercept, or it could be the x-intercept, or whatever you have, because this is going to separate our positive and negative values. So if you look, we've taken our equation, set it equal to 0, and we solved for 5/3. Here's the significance of that. We've got our graph. Looks a little bit like this. This value right here is 5/3, and that's where the break occurs. So we're looking at the interval from 0 to 3, and there's a break at 5/3. That's going to be important to me because I'm going to have to break this thing up into two different parts. We're going to have the part that's underneath the x-axis and the part that's above the x-axis. So in the next slide, this is what I was referring to, how the publisher's PowerPoint goes in and they solve this a little differently than I would. I would suggest that we take our interval and go from 0 to 5/3 of 3t minus 5 dt. Okay. Plus, now we're going to have the interval from 5/3 to 3 of 3t minus 5 dt. Okay. Now, if I take the integral, I'm going to have 3/2 t squared minus 5t, and we're going to evaluate that from 0 to 5/3, plus the integral. It's the same thing, right? 3/2 t squared minus 5t, and we're going to evaluate this from 5/3 to 3. Okay, so I'm going to plug in 5/3. So we'll have 3/2 5/3 squared minus 5 times 5/3. Now I know there's a lot of fractions going on here and these things can get ridiculous, but again, I wanted you to see the important part of this, okay? So when I plug 0 in, I'm just going to get 0. Now I'm going to go over here and I'm going to going to plug in 3 and then 5/3. So I'm going to have 3 halves, right? 3 squared minus 5 times 3. So remember, with total distance traveled, we said that any of our negative values we're going to have to make positive. So this is 5 times 3. Now I'm going to plug in and I'm going to subtract what I get when I have 5/3. Okay, so we're going to have 3 halves times 5/3 squared minus 5 times 5/3. Okay, so this represents the displacement. Remember, I said that any values that fall below the x-axis, I've got to make positive. So I'm going to go in right here and I'm going to have 3 halves times 25 over 9 minus 25 over 3. So I could adjust this by going ahead and changing this 3 right here, but I'm going to hold off just to make sure that I have all my numbers correct. So we've taken care of this, we've got our 0 there. 3 squared is 9, and 9 times 3 is 27. So we're going to have 27 over 2 minus 15. Now we've got another set of things. So remember, I plug in the top number. That's what I get here. Then I plug in the bottom number and I have to subtract. So we're going to have 25 over 9 times 3 halves. We're subtracting 3 halves times 25 over 9. And then I'm going to have, now this minus sign needs to get distributed into this guy right here. So we're going to have plus 25 over 3. Now again, you might look and say, oh, these cancel, but remember, this stuff is what comes from below the x-axis. So when I combine this, I have to take the absolute value of it, okay? So I didn't put that absolute value in just yet because I wanted to stress the importance of, look, any value that comes out negative, we have to take the absolute value. So all of this stuff is what's actually below the x-axis, okay? And again, I know that because in looking at the graph, 5/3 is here, and the interval from 0 to 5/3 is below the x-axis. So let's go ahead and look at what our answer would be. Okay, we're going to have 3 times 25 is 75 over 18, right? 75 over 18 minus 25 over 3. So I'm going to multiply the bottom by 6 and the top by 6. Okay, so that's going to give me 150 over 18. And again, I'm taking the absolute value of that because when you do 75 minus 150, you're going to get a negative value, right? You're going to get a negative 75. So I need to make sure that that value winds up positive, okay? And then I'm going to have 27 over 2 minus 15. There's a small 15 there. This is going to be minus 75 over 18. Again, I don't want to combine these yet because there's absolute values right here. So I've got minus 75 over 18 plus 25 over 3. Okay. Now remember how we said this is going to combine, what I have right here is going to combine to give me a negative 75 over 18. But when I take the absolute value, it turns into a positive 75 over 18. So positive 75 over 18 right here. Plus 27 over 2 minus 15 minus 75 over 18 plus 25 over 3. So we can see now these 75 over 18s cancel. I've got 27 over 2 and 25 over 3. So I'm going to get a common denominator. I'm going to multiply the bottom here by 3 and the top by 3. So 27 times 3 is 81. Right? So 81 over 6 plus 50 over 6 minus 15. So again, we're working with these fractions, getting the common denominator. I know that's really, really confusing. If you're not familiar with fractions. 81 and 6 combined to give me, 81 and 50 combined to give me, what's that, 131 over 6 minus 90 over 6. So again, I'm getting the common denominator. I'm going to multiply 15 by 6. That's going to give me 90. 131 minus 90 over 6 is, what's that, 41 over 6, okay? 41 over 6. So let's check and see how we did against, yeah, so look right here. So in the problem that the publisher did, they still got 41 over 6. Now notice they don't have an absolute value in here. They have it at the beginning. Where I did this, I took the absolute value at the end. Again, you're free to do the problem the way you want to. I always tell my students, I don't care how you do it as long as you get the right answer. I should also add, I don't want you looking at anybody else's work. Try to come up with the answer on your own. But what I mean is create your own method by which you're working, right? So find what's comfortable for you and work within that. There is another problem where we do something similar, okay? And so you can read through and look at how they did this problem. So what happens is right here, Newton, the publisher, is saying this integral is equal to the opposite of the part that's under the radical plus the part that's, opposite the part that's under the x-axis plus the part that's above the x-axis. So if you were to look at this function, t minus 4, it would cross the x, or it would have a y-intercept of negative 4, right? You go down 4 and then up. So this is the part that's under the x-axis, and that's why we put a negative right here, because we want to take the opposite of that. This is going to come out to be a negative value, so putting a negative in front makes that positive. Again, if you wanted to see how I would work that problem out, it would be similar, except I wouldn't have this minus sign here. So let me do that real briefly. I'm going to insert a new slide here. Give me just a minute while I clean this up, and we'll take a look at how that problem is going to work in case you wanted to do it differently. So we're gonna set t minus 4 equal to 0, and we find out that there is a 0 value at t equal 4. So if I wanted to find the total distance traveled, right, if you look right here, find the total distance traveled for this integral 0 to 8 of t minus 4, right? So t minus 4 between 0 and 8. Find the total distance traveled up to 8 seconds. So I'm going to have the integral from 0 to 4 of t minus 4 dt. And this is going to be a lot cleaner than the one we just did. It's not going to have the intense fractions. And then we're going to have 4 to 8 of t minus 4 dt, right? So if I take the antiderivative, I get t squared over 2 minus 4t, and we're evaluating that from 0 to 4. And then we're going to go and we're going to take t squared over 2 minus 4t and evaluate that from 4 to 8. Again, this is the part that's going to be under the radical, so I'm going to put that absolute value there. In other words, I got to make sure that I make that negative value positive. So now it's just a matter of plugging 4 and 0 in. So this is 16 over 2 minus 8, right? We're taking the absolute value of that. 16 over 2 minus 16. Sorry, I had a minor slip there. Plus, we're going to plug 8 in. So we're going to have 64 over 2 minus 32. Right, times 4 times. So 8 squared is 64 over 2. And then, so when I plug 4 in, I'm going to subtract, right? And I'm going to subtract 16 over 2 minus 4 times 4. Okay, so the subtraction sign is going to have to be distributed. This is essentially what we're saying. 16 over 2 is 8, and 8 minus 16 is negative 8, right? So all of that is negative 8, but the absolute value of negative 8 is 8. This is going to turn into 0, right? Because 64 over 2 is 32, so that's 0. Minus 8 plus 16. So the total distance traveled is just going to be 16. Again, we can see how that plays out right here, right? So here's where it's worked out as the publisher's PowerPoint. 16 meters is the total distance traveled. Okay, so this last problem gives us one where we have 2 points, right? If we set this thing equal to 0, we're finding total distance traveled, and the first thing is to go in and find out where does this thing equal 0. Well, it equals 0 when t is equal to 1 and -1, but we don't consider -1, and the reason we don't is because it's not within that boundary. So I know this was kind of an add-on to what seemed to be a long video anyway. Total distance traveled and net change can be it can be a little tough to get your hands on. So I wanted to give you this additional video as just a way of solidifying what we talk about and giving you a good foundation as you go into the problems in Newton. So good luck. Let me know how I can help.